So yeah, hello everybody. I'm Matt. I'm an AWS community builder and AWS ambassador. I do work for a living as well. I work at an InsurTech called CDL, based in Stockport near Manchester. Basically, we use data and AI to power digital insurance journeys. About this time last year, we held our first DeepRacer event. So this is what this talk's about, how we use DeepRacer basically to scale AI education across our organisation. So what is DeepRacer? Well, it's a fully autonomous 1/18th scale car designed by AWS, really for the purpose of machine learning, reinforcement learning, education and experimentation. It's part of AWS's broader initiative to make machine learning and AI in general more accessible to developers and also enthusiasts. They use DeepRacer often as a learning tool, allowing developers to gain some practical experience with reinforcement learning, deep learning and robotics. Certainly we found it to be a really fun and educational way to get hands-on experience with AI and machine learning with a real-world context. Have brought DeepRacer in if you've never seen one before, but if you've ever been to like an AWS summit, you've probably seen one of these cars going around a big track. But yeah, feel free to have a look later on. So to supplement the service itself, AWS also created a really good community around DeepRacer, and it hosts DeepRacer league competitions where developers can compete and test their reinforcement learning models on physical tracks. Ultimately, the best racers get to qualify for the grand final, which is held at the AWS conference reInvent in Las Vegas. In 2023, there was about $43,000 in cash prizes up for grabs for the top racers. Sadly, I'm not one of those. The first place champion actually won $20,000. So as well as having fun, it can be quite lucrative, I think. Okay, so this is where I'm going to introduce George, because George is really excellent at teaching us all about an area of machine learning called reinforcement learning. So here we go. George's got lots of toys, but his favourite by a long way is his ball. To get his ball, George has to be well behaved. So here we can see that whenever George completes a task, like a high five, a spin round, or a roll over, he does have more as well, we tell him he's a good boy and we throw the ball for him. This is reinforcement learning in action. George knows exactly the behaviours we want of him in order for him to get his reward. So, reinforcement learning is a type of machine learning that focuses on training agents to make sequences of decisions in an environment in order to maximise a cumulative reward. It's inspired by behavioural psychology, and it's often used in scenarios where an agent interacts with an environment to achieve a specific goal. So reinforcement learning can be understood through a few kind of key components. First of all is the term the agent. So this is the entity that is learning and making decisions. So in the context of reinforcement learning, this is typically a software program. And we have our environment, so the external system in which the agent interacts. So this environment is where the agent takes actions and receives feedback or observations. And we have our state, a representation of the current situation in the environment, which includes all the relevant information needed for decision making. And then an action, so a set of possible moves or decisions that an agent could take in a given state. And then our reward, value provided by the environment after each action, which indicates how good or bad that action was in achieving the agent's goal. So the agent's objective is to maximise that cumulative reward over time. So we have policies, so a strategy for mapping from states or to actions that the agent uses to make decisions. So the goal of reinforcement learning is often to find an optimal policy that maximises that expected cumulative reward. And then we have our reward function. So this is a function that estimates the expected cumulative reward an agent can achieve from a given state or a set of kind of state action pairs. It helps the agent essentially evaluate the desirability of different states or actions. So DeepRacer is using reinforcement learning. The car learns to make decisions by trial and error, to put it simply. If you've not seen one before, this is an example of one of the reward functions that AWS provide in the console. I think it is one of the default ones. It's not one I've written. Code's in Python here, but basically if you look at the kind of if, then, else section towards the bottom, what you can see here is us rewarding higher values the closer the car keeps to the centre line of the racetrack. DeepRacer, it comes with a simulated racing environment where you can build your models, simulate races, and test your model's performance, and then iterate on that training without the need for a physical car or track. So as I said, last year, between about April and July 2023, I put together a team at CDL to run a DeepRacer event. And the aim of this was to scale AI education across our organisation. Success was defined at getting about 30 people to participate and learn more about machine learning. So I'm going to basically take you through the organisation of that event. So the first thing is that we had our AWS account team arrange for a guy called David Smith, who is a solutions architect within AWS ML. A massive shout out to David, because I think he's just announced on LinkedIn that he is leaving AWS, and David has been like a massive help to anybody that's ever done anything to do with DeepRacer in the community. If you've ever been to an AWS event where there's been a racetrack, David is the guy that made all that happen. I'm sure what he does next is going to be just as good, but yeah, he's been a massive help to us. Yeah, so I'd say David is the person that you see at the AWS summits and reInvent leading the pit crew. We were very fortunate to get him on a call, and he ran a number of sessions with our team at CDL. So the first session covered like an introduction to DeepRacer, machine learning, and the reward functions, about 26 minutes in length. And then we moved on to training our first model, about 40 minutes, and then we had about 20 minutes of Dave's time for Q&A. After the Q&A, we had a bit of a break, and then we got back on a call with David a few hours later for further Q&A once everybody had got the chance to actually build a model. So our aim was for 30 people. The session attracted 105 attendees. And after the first session with David, he shared a number of follow-up resources to help our team continue their DeepRacer learning. So this was in April, so we really wanted to keep people engaged with DeepRacer and ML and AI until the final race happened in July. So we thought quite a lot about how we would keep people interested. So about a month after that initial engagement with AWS, we had a couple of extra check-in sessions with our AWS account team. So the first was like a pro racer session, people who wanted to do really deep dives on particular topics. And then we had a second session, which was maybe for people that missed the first section or who were from a non-technical job, who were still getting started with DeepRacer and wanted to ask more basic questions. And then a month before the final race, we had our track in place and we had a timer system working. So what we started to do was offer weekly check-in sessions trackside. So these type of sessions allowed anybody to actually bring their model that they've been training online in the console, and then together with a member of our pit crew, we would help them race around the physical track. We offer remote working, so not everybody was able to attend, so we offered a remote service as well, where basically people could send their model in, and a member of the pit crew would record in video form the car going around the track, being raced on the model. What we found was this time on the physical track proved to be one of the most popular sessions, and we were often oversubscribed. Having the chance to tinker with the track, the cars, play about, even crash the cars, also really helped train our pit crew up for the final race. Some kind of other engagement tips. So in between the different sessions we had with AWS, we tried a number of things to keep people interested and build momentum up to that final race in July. So we wrote some blog posts. So one of the pit crew wrote about their experience of training models and offered hints and tips. And we set up a race track, so we use Office 365, so we had MS Teams and hosted a chat with racers. So this helped really build up a healthy competition, I would say, between the teams and offer support and answer questions and debug issues. We also took our models to some of the in-person DeepRacer meetups. There's not that many of them. There is one in London, and that's where we went. So JP Morgan are a big user of DeepRacer, and they have an excellent track which they let people use, which is very kind of them. And we also took our models to the AWS London Summit, and because we'd had that engagement with David and his pit crew team, they let us to the front of the queue, which again was very kind of them. And we got to try our models out at the summit. We also used the chat to kind of post live feeds of other various DeepRacer events that were happening at the various AWS summits across the world. Okay, so within the DeepRacer section of the AWS console, we created a CDL league, so this is for the virtual racing, so allowed our racers to submit their models to a virtual league over the 3-month build up to the final race. So this is the final position of the leaderboard. But as you probably can see here, so far all this training and racing has been largely virtual, but we have these cars, so we want to put our models into action and see how they respond in the real world. And for this, you have to think old school. You can't call APIs for that. You have to get involved in building nuts and bolts and actual physical things, which can be fun sometimes too. So step one, you need a track. This is ours. So we used the 2018 DeepRacer track. This is the smallest track available. So it kind of provided us a bit of flexibility on location. So the track is now referred to by AWS as the A to Z Speedway. The track size is 8 meters by 5 meters. We were advised that carpet-based tracks have fewer issues with light reflection than their vinyl alternatives. The spec for the track is available, I think, in an Illustrator format on the AWS documentation, so you can download that, which is what we did. And we sent it off to basically a printing company. So the cost of our track was just over £1,300 to have it printed onto carpet. And you can probably just see the joins there. There's 3 sections that this track was delivered to us in. So this next thing is probably the main thing I would change for future events. It's the barrier. So there is an A to Z Speedway printed wall barrier for the AWS DeepRacer track on Amazon.com. But after kind of looking into it, the issues around delivery to the UK were going to be problematic. It's also quite expensive. I think it's about $2,700. So I decided I was going to build my own. So I bought 30 sheets of green plastic Corex board. So this is the type of board that you see like estate agent signs made out of. I got 4mm thick and A1 paper-sized sheets. To join this Corex board together, I bought some plastic shower screen strips. Just so happens that shower doors are similar thickness to the plastic Corex board. So I used about 8 2-meter length of the straight seals, and then they have corner seals as well. Cut these to length with an actual saw, and then kind of fitted all these things together. Just a note, like if you're going to look at building the barrier, probably don't just try and get somebody to make you one, being my first tip. Also, notify like your finance team, because it really looks odd when you've got about 800 quid's worth of bathroom supplies on your expenses claim. They don't really like it. So the barrier, because it's quite lightweight, those plastic boards, it was quite flexible as well. So you can probably see around the side of the track, I repurposed some desk drawer furniture at regular intervals there. Then we've got some branding on here, so the company logo and AWS designed us that DeepRacer logo. and we sent off to Sticker Mule for some big wall graphic stickers. So the kind of stickers that you can see there, 5 copies of each, cost about $63. So like I said, the barrier does have a couple of issues. It's too flexible in the gaps where I've not put those desk drawers. So this meant that the cars could crash into it, and then basically the Correx board would detach from those jointing strips. Where there wasn't a gap, where it was reinforced with desk drawer furniture, the car would occasionally get damaged when it hit those things at high speed. During the actual racing, we did have to fix the car shells, which is basically the plastic thing that sits on top of it, a number of times with black gaffer tape. We also had to secure the camera with elastic bands. They do have a tendency when they crash for the camera to pop out of the USB ports you see there. This is James. He's one of the AWS Solutions architects. He was part of our pit crew. This was his camera safety device. I believe it is still patent pending. You do also need the cars. Effectively, these are an Ubuntu Linux box on wheels. The completed models get loaded onto the cars so that they can be raced. We ordered what's called 2 DeepRacer Evos, which is basically the kit you see here. So that is not fitted with an Evo kit. So the normal DeepRacer car comes with a single camera, and then the Evo kit is the LiDAR thing you see in the middle and an extra camera with the extra shell to give it more room. So we ordered 2 cars with the Evo kits. I already had my own, so we had 3 in total to work with. Each car comes in 2 boxes, the original DeepRacer car and then the Evo kit. You can only get them sent to a US address, fortunately, so we had to use a US mail forwarding company. We used Shippy2 to get the cars shipped to the UK, so this does have an extra cost. Delivered 2 cars to our office in Stockport was about £700, I think. So then for the actual racing events, we don't actually use the Evo kit. So this kind of matches what AWS do at their events as well. The cars need to be calibrated following the instructions within the DeepRacer car console. We found, and AWS agreed, the cars can be very temperamental. We found that calibration mode wouldn't work sometimes, and we learned quite a few different hints and tips about car maintenance and calibration. It's too long to include in this talk, but I have written a blog post about it where I go into these hints and tips, so scan the QR code and get the blog post. You do need an iPad or similar to kind of control the car speed trackside, so we had a couple of iPad minis, always had one on charge to make sure that the event ran smoothly. Also, batteries are really important, so we ordered a load of spare batteries for the car. There's a battery for the motor, and then there's a compute battery, so you need both. Again, battery management, more tips on the blog post. So we needed to be able to have a fair competition. So in order that the lap times could be accurately captured, we had a pressure sensor based timer added to the track. In early 2023, there was kind of a DIY version, which is kind of the top thing. By the final race in July, we actually ended up 2 versions because somebody's done a prefabricated module that became available after we'd built our own. That's the prefabricated module down there. Just buy that, it's far easier, especially if you're not very good at soldering like I'm not. But if you want to build your own, the sensor at the top left is a sound sensor. And basically, we desoldered the microphone from it, and then we replaced it with a pressure sensor, which is the strip you see in the top right there. The completed pressure sensor is then attached to, we basically attached it to some thin card, and we added some checkered flag tape. You can see it down there, so it looked a bit cool. And then gaffer tape is vital in deep racing as well. So gaffer tape sticks the whole thing in place to the track. So we've got cables from the pressure sensor. They were running under the track and connecting basically to the GPIO pins on a Raspberry Pi. The DeepRacer community have already open sourced the timer code you can see running there on the laptop. Basically, when the car goes over the pressure sensor, the lap timer is started, and then we capture a lap every time the car crosses the line again. Okay, so I've mentioned this pit crew a few times. The pit crew are the hardest working people during a DeepRacer event. If you're going to run an event, do not underestimate how vital they are to keep the event running smoothly. So there's a few roles within the pit crew. Some have official names and some we've added to supplement our specific needs. First one is the track boss. So the track boss's job is to monitor the car as it races on the track and basically put it back on the track if it crashes or comes off. This is really hard work. You're going to need to rotate this person after each race, and they certainly don't need to go to the gym after work. Then we had our mechanics. So these are basically charging the batteries and swapping them out within the cars and doing all the calibration that I talked about, and fixing the cars also if any parts fail. So then we have the person in charge of the lap timer. So they're basically in sync with the track boss to capture complete laps or disqualify any invalid laps. And we had what we call the team liaison. So this was finding the next team to race, explaining how to use the DeepRacer car console via the iPad, and then getting them ready to race, essentially. And we had a person doing commentary, so basically helping the event flow, and also to help out people watching in person or via live stream by making announcements, doing interviews, or just general comments on all the action that was happening. We had a load of swag, so we had people dealing with the merchandise. We had people dealing with the AV, so connected up all the AV equipment, sound checking and checking on with the live stream. We also had an official photographer capturing the joy and or pain of the winners and losers. Basically, that team is vital to the racing structure. So our pit crew established the running order for the event. So each race, typically within DeepRacer, is 3 minutes. And within each 3 minutes, each team can complete as many laps as they're able to. And it's the fastest of their laps, which is what establishes their position on the leaderboard. So we knew the number of teams taking part, and we also did some estimates of how long it would kind of take to put the car on the track, get each team into position, and complete 3 minutes of racing. And we validated with AWS that between 5 to 7 minutes per team was about right. For us, this did work out correctly, but our pit crew didn't get any time to relax at all. We are told that this is normal for the AWS run events too. There's kind of an unwritten rule that everybody on the pit crew should be busy and active at all times. We held 2 racing sessions with an hour break for lunch. So we started about 10 a.m. and we got all the teams to complete 2 lots of 3-minute races by about 3:30 in the afternoon. There was some debate amongst the teams if they should try like different models in between sessions. We didn't really come up with any real conclusions on this point, but we did notice a few kind of real world effects on the cars and the models. So environmental factors definitely do impact model performance. For example, we did some testing with lighting prior to the event. We basically just went with what we found to be most reliable, so we generalised. Again, I will call it healthy competition amongst teams led to a feeling that certain cars were more reliable than others. We don't have any real world evidence for that. We did try to support teams by advising them to kind of start their models at a slower speed and experiment in speed adjustment with the iPad over the 3-minute racing time that they're allowed. Basically then, once you've got a kind of speed benchmark established, you can make further adjustments within that particularly as the car goes around corners, typically slow it down, or as it goes on the straight there, you can speed it up. So some stats. In total, 105 people trained. In terms of model training time, we wrapped up 1,205 training hours. We had 25 teams take part, and this comprised 71 racers. Our model storage in the end added up to 179 gigabytes, and we had 75 virtual racers take part in the online league. And we burnt through $4,278 of AWS costs. Fortunately, we're an AWS partner, and we put in a credit claim, and they gave it us all back, which was nice. So hopefully this is going to, bit of a video here. This is Debbie, who's one of our project managers. Hopefully the audio is going to be loud enough. I think it's fair to say that Debbie was a little unsure about taking part at first. But one of the things we wanted to challenge was that machine learning was just for people in our software engineering roles. So after a bit of a chat, Debbie formed a team with other project managers, and they not only took part, they ended up getting a really good lap time, 9.251 seconds. Here's what Debbie thought about the event.
So what technical skills have you learned as a result of doing this?
I'm probably one of the most non-techie members of DeepRacer. I think that's fair to say. So for me, going into the AWS console and learning about machine learning, I've got a bit of an interest anyway, but it was really good to play around. Just understand how you can fine-tune models, how easy it is to almost plug and play, and what results you can get from it have been really, really interesting. Obviously, when I first logged on, I think I was saying to Matt Horton that the hardest thing for me was probably actually logging into AWS's sandbox. But once you've got the tutorials on one screen and you've got the console on the other, it's really easy to play around. And then once you've done it once, you get addicted, so you want to fine-tune it again, run it again. But yeah, I think it really hits home when you come on site. So the team came on site, like I said, and when you actually see them going on the track and what happens, it gets quite exciting for the team.
So there you go. So that was an interview filmed actually during the championship race in July last year. As you could probably hear from the background, there was a lot of noise there, and that was really, the campus was really buzzing that day. A lot of people had come in especially for it, and as you'll see a bit later on, we got some really positive feedback about all that. So yeah, I kind of mentioned like Debbie's time there. Here's some other times. So this is the top 4 at the end of the day in July. To put this into context, I think last time I checked, the world record was set at the AWS Summit in Taipei. I'm not sure if it still stands, but it was 6.002 seconds. So for effectively first-time competitors with a few months to build a model, we're pretty pleased with some of those times. Okay, so some kind of feedback. So we took a survey as part of the event. So we spent about £4,500 on DeepRacer, so on things like the car and the track, and this resulted in 105 people attending and doing kind of machine learning training. And we asked, did we think that that was good value for money? So most people did. So we look at the use of our campus. So we've got quite a nice campus in Stockport across 3 buildings. So we wanted to ensure that we made good use of it, and was DeepRacer a good fit? So again, overwhelmingly, people did think it was good to have this on our campus. Collaboration was the top thing. So did people think that DeepRacer had encouraged or improved collaboration? And everybody who took part agreed that it did. So I mentioned before about us wanting to not only attract technical people, so we measured what business unit people worked in. So we are a software company, so obviously software engineering is our biggest area, and that's shown in the graph. But what we were really pleased with was the other areas that took part. So effectively, I think apart from one business unit, we had representation across the whole organisation in participation, which was good, which was really cool. So we measured as well technical levels. So how technical is your job? So 1, I don't work in a technical job. 2, 5, it's very technical. There's quite a split of different levels there taking part. In terms of actually creating a model, so getting those ML skills, did people actually manage to train at least one model in the DeepRacer console? So 83% actually did manage it. On training a model, did they actually submit that to the virtual race? So again, 76% of people did. And finally, do we want more AI education? So 89% said that they would take part in other AI training or events. 76% said that they would take part in an AI community of practice. And 89% said that they would take part in training on other AWS AI services. Would they actually do DeepRacer again? So 94% of people said that they would take part in another CDL-only track event, with 90% of people wanting to take part again in the virtual aspect of DeepRacer. And 80% said that they would take part in joint CDL and customer DeepRacer events. So what's next? Well, we're currently looking to run future DeepRacer events. We hope to run one again in July this year. When I go back to work tomorrow, we're sorting the track out and connecting up the sensor again. We've also been running a series of AI days. So last month, we essentially ran a bake-off of AWS and GitLab code companions. What we found was the results were really promising. So people who used AWS Q Developer completed coding tasks around 50% faster than the control group who had no AI assistance, despite the AI-assisted group having a lower average skill level overall. We also have been running workshops for Gen AI, in particular the Essentials badge that Amazon offers to partners. So just on one day, we had 48 people gain that accreditation across the organisation. And the knowledge gained from these foundational things are really important as well, because it allows people to be confident. So when you get that badge, you can confidently define what generative AI is. You can explain how Gen AI works. You can describe the benefits of using AWS for Gen AI. You can describe key AWS Gen AI services. And crucially, you can identify potential customer use cases for generative AI. We also ran some breakout sessions on prompt engineering, Amazon Q for Business, Party Rock, and Amazon Q for QuickSight. And having this exposure to lots of AI services and training opportunities is just really important, we think, to all areas of our business. So that's the end of the talk. Thanks very much for having me, and thanks for listening.